So in this episode we'll be looking at the conservation of energy, but before we do so, there's a few things that you need to know to make the conservation of energy as accessible to you as possible. And those are, first of all, an understanding of energy and work, that energy and work are measured in joules, and that there are energy stores and transfers. Know that there are different examples of energy stores and transfers, and in a previous video we went through a mnemonic to help you remember those. So we had CK Getmen for energy stores and Mr. He for energy transfers. In this lesson though, we'll be covering the principle of conservation of energy and how that links to something referred to as a closed system. And then we'll be looking at different changes in systems and how stores and transfers are involved in those system changes. And also that every time that there is an energy transfer, that some thermal energy is transferred to the surroundings, and that we'll be using the word dissipated to describe that transfer of energy. So, the principle of conservation of energy. Well, firstly, understanding what the word principle is, and that's a foundation of a rule. And really, the principle of conservation of energy is the foundation of physics, really, because nothing in physics can ever break that rule. But it has to be considered to be a closed system because energy can be brought in from outside the system and appear to break it. So, for instance, if I have 100 joules of chemical energy inside me, that means I can do 100 joules of work. However, if I bring some food in from another system, and I eat a Mars bar with another 100 joules, I could do 200 joules of work. But that's only because I brought in energy from another system, that other system being the fridge or something like that. So the principle of conservation of energy states that in a closed system, energy cannot be created or destroyed, but it can only be transferred from one store into another store. So you can see that knowing what the stores and transfers are vital in this part of physics. So if we have a look at that statement again, you can see that I've highlighted closed system. So the closed system does not interact with any other system. It's really important to understand and realise what that closed system is. And what we'll be doing is having a look at a few different examples so that you can get an idea about the closed system. And in another video we'll be looking at more examples with numbers involved to help you understand that a little bit more. So let's have a look at a first example. In this first example, we're going to have a look at a simple one with a battery in a closed circuit with a light bulb. So we're looking at the energy transfers and stores involved in that, linking it to the principle of conservation of energy. So we look at the battery has chemicals in it, which means the battery has chemical energy store. And it will transfer that in a closed circuit electrically because there are charged particles, those delocalized electrons involved, and it will transfer the energy from the battery electrically through to the light bulb. Once at the light bulb though, the light bulb will firstly get warmer, so it will heat up, and that means its thermal energy store will increase, and it will also transfer some thermal energy to the surroundings. That's because it is hotter than the surroundings. And it will also transfer radiation energy to the surroundings in the form of light, which we used to see. So let's have another look at another example. Let's consider a wind-up toy. So we'll start at the point that it's actually been wound up. So if it's been wound up, that means there's elastic potential energy store. So elastic store stored in the wind-up toy. And when released, it's going to be exerting a force. So that means that that energy is transferred mechanically. And that mechanical transfer of energy will increase the toy's kinetic energy store. But there's also friction involved, so it's not the only transfer involved. So the friction acting on the toy will increase the thermal energy transfer to the surroundings. There might also be radiation transfer in the form of sound, as they're usually very noisy. And let's have a look at a third example, and a simple one again, just a person running. So to do any work, people must have food inside them, so that is our fuel, and that's a chemical energy store. And our muscles exert forces, so that means that if there are forces involved, we then transfer that chemical energy store mechanically, and that increases our kinetic energy store. It's not the only transfer that takes place. Sometimes we get very, very warm when we're running, so that means our thermal energy stores increased. It also means that we might transfer some thermal energy to the surroundings, and we refer to that as dissipated. It's a very good word to use in physics to describe energy that's been transferred to the surroundings, and we can't ever grab it and use it again. It's wasted completely. And we can also maybe produce some wasted radiation energy in the form of sound when we run. So an important part of physics is that any time that energy is actually transferred, some of it is transferred into thermal energy and to the surroundings, and it's wasted. And I keep mentioning this, but we can't get away from that. We can reduce it, but we can never stop it. And it's a good word to use, but I keep referring to it, it's dissipated. So at any time that thermal energy is transferred to the surroundings and it's considered wasteful, we can say that thermal energy is transferred to the surroundings or dissipated to the surroundings. We can never use it again usefully. So that's the end of this lesson on conservation of energy. Don't forget to hit the subscribe button and come back for more lessons soon on different parts of physics to help you understand physics more and hopefully improve your grades.